Welcome to this lesson. So in this lesson, we want to look at section 3 of domain 2 of Microsoft AI AB-100 examination, which is agentic AI solution architect. And this in this domain, we'll be looking at designing AI-powered business solutions, basically designing agentic AI-powered business solution. That is what we have there. And the core key takeaway we have been looking at is agent design, extensibility using MCP and action and computer use and Foundry, and orchestration, integrating with Microsoft 365, Dynamics 365, and Power Platform. So let's look at what we have next. Please, if you are just joining us, please kindly like and subscribe to our channel to increase to increase our views and also help us reach the subscriber level. Thank you. Okay, let's look at Microsoft Foundry. So we've discussed a lot on Copilot or tool use in Copilot, how you can connect Copilot to knowledge sources, how you can integrate Copilot with Dynamics 365 application like CRM, sales, and how you can also build conversation agent using Copilot, voice email, how you can also build prompt and response agents and task agent in Copilot Studio. Now let's look at Microsoft Foundry, how you can implement and build agent with Microsoft Foundry and where you should use Microsoft Foundry. So post Foundry tool for requirements. So these are requirements for using Foundry. So before you use Foundry, it is important that you know the requirements, know when to use Foundry, know the requirements that warrant the use of Foundry. Okay, you can't just take every agent to Foundry. You can build some of the agents we have said in Microsoft 365 Copilot, and there's some that are beyond the work of 365 Copilot, like task agent, like response agent, like sales agent, CRM agent. Then you build them in Copilot Studio because Copilots have a lot of capability as well. And then when you want to build custom agent, then you can use Foundry. When you want to build very complex and custom agent, that is when you should use Foundry. And these are requirements for using Foundry, and these are their two categories. So knowledge retriever, this is RAG database. So if you want to implement RAG database, like a knowledge retriever, vector database, retriever and indexing, then the two that you can use in Foundry are vector search, AI search, hybrid search, and grounded RAG. Okay, so combination of vector search with keyword search is called hybrid search, which is much more stronger than using vector search or keyword search alone. Okay, it improves semantic indexing, and they allow agents to generate personalized information and answers. So it's grounded RAG, so it's used for grounding RAG. So if you are using RAG database, these are the tools category that you can use in Foundry. Then CRM integration. So the two categories for CRM integration are connectors. You can use connector to connect to CRM. You can use APIs. You can use tools. You can use Dataverse and Dynamic 365 integrations. All these are available in Foundry for CRM integration. For Dynamic 365 customer relationship integration, we have automation. So automation tools that you have in workflow are workflow tools, actions, Power Automate, and agents tools. And then we have data processing requirement. For data processing, you can use tools like Azure Function, which is available in Microsoft Azure. We have data pipeline like Azure Data Factory or Databricks or Azure Batch, depending on the complexity of the data. So, but for streaming and real-time, processing, you can use Azure Function. Then we have preparation logic. Also very, very important. We have planning and reasoning requirements. You can use reasoning tools, which is available in Foundry. Use orchestrators, which is also available in Foundry. You have evaluation tools in Foundry. You have model routing in Foundry. So all these tools are available. So Azure AI Search is part of the Azure OpenAI ecosystem for building a RAG database, and you can use it to perform hybrid search, vector search, and grounded RAG. So all these tools are available for use and integrate with Microsoft Foundry. So grounding design. So how do you design grounding? So this is how you can design a RAG database. So to augment the retrieval of information of LLM or your base model. So data processing for model and grounding. So to design a grounding database or your RAG design, follow this pattern. The first thing is to ingest information from various sources. It can be from document, it can be from database, it can be from Azure SQL database, your operational database, company operational database, it can be from warehouse where historical data is seated, it can be from lakehouse, it can be from Wall Lake, it can be from SharePoint document, policy document, enterprise document repository. It can also be from OneDrive. So ingest data from wherever they are, then prepare the data for chunking. The data must be clean before it is chunked. If not, it will still contain hallucination and irrelevant data, which will still not allow the agent to generate a quality answer or quality output. So make sure the data is prepared. Okay, these are the the work that data engineer can do. This is where data engineer comes into play here. They are the one that will ingest the data, clean the data, transform the data, make sure the data is properly structured and properly ready for chunking. So when the data is prepared, the next thing is chunking. So for RAG database, you can use cosine. We have cosine distance, which uses the cosine formula. Cosine formula is defined like this. So I've taught cosine, uh, you know, I taught cosine rule in one of my teaching in the video. You can watch my lesson if you're interested in the mathematics beside the chunking, embedding, and indexing. You can watch that video to understand it more. So for embedding, if you are embedding maybe a RAG database, for instance, you can use what we call uh, the Euclidean distance or the cosine distance. So for cosine distance is normally the best that is being used. We have scalar product all over the magnitude of individual vectors. So these A and B are your data, for instance, are the distance or the coordinates numerical location of the data in the database, and then these are their cosine distance cos theta. Okay, so this is cos theta of all this. So this is how you calculate cosine. You are not the one that will calculate it. It is the system that will calculate it by itself. So it's normally assign distance or assign location of an instruction in the database using cosine distance or Euclidean distance. But most RAG databases like Azure AI Search and everything, it uses cosine distance for correctness. Okay. So we have chunking. So after preparation, the data is chunked. So we have chunk scripts. So all these have are function, Python functions or LangGraph framework that you can use. So chunking. So when you chunk the data, so chunking is dividing the data into section or into context that the AI can easily understand. So for documents, you can chunk it to paragraphs or phrases, but make sure the phrases are also meaningful. Also be careful when you are chunking. So because these are complex operations that you should also know how to do by going in, grounding yourself in the knowledge of vector database development. So the data is chunked appropriately, and then after chunking, it is embedded. Embedding is just like using this cosine formula to store the data in the vector database. That is called embedding, using uh, using numbers to represent all the chunks. It's called embedding. So in mathematics, we call it numerical ranges, using numbers to represent vectors, turning text into numbers as vector numbers is called embedding. It's a form of representation in an advanced mathematics which is being taught in a MSc level mathematics under functional analysis. So we have embedding. Embedding is done where all this information are turned into a numerical distance or numerical ranges. Then it is after embedding we have indexing. So when they are embedded as a vector store, then they are properly indexed. So where they are indexed is where they are assigned a coordinate in the database, a location where they can be fetched. So the location are also defined in form of a number. So they are indexed, and then the LLM can now use retriever function to retrieve information from the indexed vectors whenever it needs information. So this is the workflow of defining, of processing and building a RAG database. This is the workflow. This is the entire workflow. For example, it may not be your work as an AI engineer, maybe the work of or a data engineer that will make this available and that will develop this. So this is basically RAG pipeline. So RAG pipeline quality depends on clean preparation, meaningful jobs, embeddings, index freshness, and hybrid search. Very, very important, as we have discussed. Use citations, retrieval validation to keep AI response grounded in trusted data. So always use citations, and make sure when data is chunked, also store data with metadata. Okay, do not just chunk data and throw the metadata away. Store the metadata, because the metadata is also useful for augmenting the information. It only receive the context and keywords from the index data, but to populate the information, you can still use metadata. So store metadata along with the embeddings. Intelligent apps. So how can you build intelligent apps? So understand these key architecture terms in building intelligent apps. So code first generative pages and agent feed. These are intelligent apps. So applications that are built with AI. These are intelligent applications. So you don't just build application like nowadays. Whether you build application with conversational chatbots, application with prompt and response agent, applications that have task agent. So applications that are built now they are called intelligent application, not just traditional software that is normally being built 10 years or 20 years ago. No, you build application that is integrated with agentic AI or AI. So we have in intelligent application, you have generative pages. Even in Power Platform ecosystem, we have what we call Power Pages now, not just Power Automation or Power, not just Power Automate. You have Power Pages now, which is an intelligent application layer of Power Platform solution. So we have generative pages, we have agent feed, we have next best action, we have code first and a business application. So you must understand this application term, architecture terms in the intelligent applications. So you should understand them and how to use them in architecture design. So the first point we have here is generative pages. Generative pages create screens from natural language and accelerate app experience design. Okay, so generative pages you can just put in natural language and it generates the page for you. So instead of you designing the page yourself, all you just do is to put the prompt into the natural language and it generates the pages for you. For example, we have this AI called Lovable where you can build websites. So you just turn your ideas and put the prompt into Lovable, and the Lovable just generate the website for you, and then you have the front end and everything, and then you can even post it on the Lovable platform there and have your website built. So generative pages work exactly like that. You just put prompt and the agent or the AI generate a power page like a user front end for you where you can just use to perform tasks. So generative pages create screen from natural language and accelerate app experience design. Agent feed. So agent feed provides recommendations, summaries, alerts, and next best action inside business hub. So this is the work of agent feed, just like you have feed on Instagram, you have feed on Facebook and everything. We just feed you what people are posting on their status and wherever. Agent feed provide recommendation from everything in the system, summaries, alerts, next best action inside business application. For example, we have in Microsoft 365 Copilot. So it knows everything that relates to your account. It knows your OneDrive, your SharePoint, what you are doing. It connects to all the files that are connected to your account. And then if you ask any question, it just uses all those information to generate recommendation summaries, alerts, and next best action for you. So we have agent fee. We also have it now in a ChatGPT that we just, if you create a project, we use the knowledge in the project and then you see suggestion of what you should do, generate summary of what is done today, or generate today's task, to store in your daily tasks as your report. You can see all those feeds. So agent, all this AI have now have the capability of generating feed from your daily activities and from your files attached to your account. Enterprise pattern. So enterprise pattern that you should follow here under intelligent app are generative pages. That's using natural language to generate user experience design from AI, then plus agent feed. That's agent connecting to all your sources, following your pattern, your information, everything you do on a daily basis to generate response, recommendation, summaries, and alert for you to follow. And then we have code first extension. So you can also still use code first extension, to build a generative application or intelligent app. So you can still use a code first to build it. So architect design where AI appears in the user journey, what action it can safely trigger. So make sure you design a architected intelligent application, either using generative pages or using Power Pages in Microsoft Power Platform ecosystem, or simply using other platforms that allow you to design this kind of architecture. But the future of major application now is intelligent application. No application will be started alone without any agentic AI operating within it. The next thing we have here is Power App. So after Intelligent App, which are Power Pages, we have Power Apps. Of course, Power App has been existing since, and then we even have a couple of certification on it. Okay, we have the solution architect, we have the developer, we have the consultant, we have the functional consultant. And one of it has been retired, but make sure one of the requirements of this AB-100 is that you should have either one certification from Power Platform, maybe PL 400, or one from Dynamic 365, whether sales, finance, or CRM. This is very, very important before the certification can be awarded to you. So we have Power Apps, design AI component in a Canvas app process. So this is Power Platform, Power App architecture. So you can follow this pipeline to build and deploy an intelligent application on Power Platform application. So the first is map workflows. So you map your workflows, okay? Have your workflow, have your tasks that you want to perform, properly split the tasks into workflow, then start mapping the workflow on the Power App page. Then you find AI opportunities. So find where AI can come in. Find tasks that you can automate with AI using agent feed or agent flow to connect. Okay, then the next thing you do is add co-pilot interactions. So when you find AI opportunity, then you add co-pilot interactions, and then you validate using governance and company policy, and then you monitor outcomes. So this is the workflow of building intelligent application in Power App. So AI opportunity include form generation. So where you can use AI opportunity in Power Platform application are form generations. Okay, you can use AI to generate form. Summarization, you can use AI to summarize, document and make. You can also use AI for recommendation generation. You can use AI for natural language data entry. Okay, and visualization where user just put in natural language and agent generate, content and visualization and meaningful information from the company data. And then you can also use AI where workflow automation is involved. So design must validate security, data scope, usability, and process efficiency. So make sure that even in this workflow, as we are designing in Power Platform, make sure you still implement the principle of least privilege, abide by company policy, and implement a role-based access control and limit data by scope. limit agent to only the data it should access, follow the compliance and the usability of the platform, and follow, make sure you implement process efficiency. All right, so let's look at Power Platform in general. So Power Platform contains, in Power Platform, you have Power Automate, you have Power Pages, and then you have Power App. So all this in one, and then Power BI is also one of the Power Platform ecosystem. Okay, so Power Platform well architected framework for intelligent workflow. So we have Power Platform, just like we have Azure well architected framework. We have the pillars, we have the 6 pillars. We have scalability, we have reliability, we have cost optimization, we have operational excellence, we have performance efficiency, and we have one other one like that. So this is Azure well architected framework. So for Power Platform well architected framework for intelligent workflow, we also have these 6 pillars. The first is reliability. So you should design resilient agents, connectors, workflow, and fallback paths. Make sure your agents are resilient. Make sure your connectors are resilient. Workflows and fallback paths are also resilient and reliable. So this is site reliability engineering. So if you design a resilient system, then it will be reliable. And then whenever there is chaos or when it is subjected to failure, it will still perform and generate quality information and output. Okay, so design a reliable system, design reliability into your architecture from beginning. Then security, protect identities, protect data, to implement role-based access control, least privilege. So protect environment and data, protect actions, protect AI outputs, and also protect prompts. Okay, so implement guardrail and use company policy and make sure everything that you're building abide and operate within the boundary of the company policy. The next pillar is operational excellence. Okay, so operational excellence is using the output of observability to determine the success of your agentic AI application. So a Power Platform ecosystem, operational excellence involves using monitoring, application lifecycle management, ALM, using DevOps using DevOps culture, adopting DevOps culture, using telemetry platform like Application Insight to collect metric and properly visualize the metric to generate insight and receive feedback from the performance of the agent, and then use support models as well. Very, very important for operational excellence. You cannot measure what you don't observe. So you must monitor and observe before you can get the telemetry data to measure the performance of your agentic AI application. Then we have performance efficiency. So under performance efficiency pillar, we have optimized latency. So optimize the speed of the agent. Okay, what should take the agent 1 minute should not be taking 1 hour. What the agent should do under in 1 day should not be taking 5 days. Okay, so make sure you optimize latency, optimize throughput. So latency is the speed with which the agent receive action and generate output. Okay, so throughput is the amount of time it takes the agent to loop through an instant or to generate output when it is asked a question. So throughput is just like measuring the output. Okay, how long it takes to generate output from a specific task. How long does it take to perform a specific task? How long does it take to work through an action and generate the output? Then we have model use. Also monitor model use, monitor token usage and token cost. Okay, that's why we said you should design for simplicity where it is required and design for complexity where it is required, so that you can maximize profit and minimize cost. So also optimize connectors. So performance has to do with optimization. So optimize latency, throughput, model use, optimize connectors, and scale and scalability. So scale when needed, and when it is not needed, do not scale. So also make sure when you are developing, start with single agent and gradually scale to multi-agent when it is required. Then experience optimization, that's pillar 5. So for experience optimization, this has to do with a user experience. So designing proper user interface that is useful to navigate and that is easy to walk through and navigate by the business owner. They are designing for business owner. You are not the one that will use it. You are not designing. The developer that design are not the one that use it. So everybody should work together to bring user experience as part of the application development and to make user understand, to let them know where they can increase the level of autonomy of the agent where needed, and let them know where they can approve as a human when the agent escalates to them to approve. So make sure you put user in experience, optimize the agent for user experience. So you can do this by improving the user interface, accessibility, adoption, prompts, and human review. So make the prompt simple. Let the agent be be developed and designed to accept prompts or whatever the user puts in. It should understand it, and it should be useful for the human that want to use it. And they also collect human review feedback so that you can also use it to improve and optimize the entire agent. Then the last thing we have here is governance. So governance enable the agents to align with, DLP, which is data protection, environment strategy, by implementing complacency and compliance with the company policy. Then it's also, enable you to assign ownership. Every agent must have an owner that will use it and that will be accountable for it. And then agents should also, or be developed within complete compliance rule. Agents should follow the rules of the company, implement guardrail, use policy as guardrail to protect the agent activities, action, and data. So these are the pillars of Power Platform well-architected framework. It is very, very important that you know it because it is part of the examination. All right, thank you. We've come to the end of this section. If you're just joining us, please kindly like and subscribe and share with others. Thank you. Bye.